Hello, my name is Raimundo Burgueño, and welcome to a sneak peek on how I design, model, and render my Voronoi wheel. I built and designed this system to help educate people on parametric design workflows. When I started releasing the images of my wheel, I got a lot of the same questions, and I hope that this video will answer most of these questions and hopefully inspire people to try out parametric design workflows. Before we get into the wheel design, I actually wanted to give a bit of lessons on what Voronis are, and how you can manipulate them to sort of take on any structure or shape that you want. It's actually the math behind it is quite fascinating, and it's found everywhere in nature. As long as you organize them correctly, you can start getting a lot of really cool effects. And the basic principle of Voronis is that they represent the space between the points. And as you can see here, I'm gonna basically show how they grow and find each other, and basically develop a line between them. And this is the basis of the whole function. As you can see here, we have to add a fake boundary because if that wasn't there, those cells would expand to infinity. So that's always the beauty of Voronoi cells is that if they didn't have their neighbor to start that line, then they would never exist. But they also love their personal space. So I thought that was always really funny about them. So I wanted to leave this lesson by showing you guys how to actually draw this without needing to use Grasshopper or even a computer. So the first thing you do is plot a bunch of random points into the paper, and then connect all those points together to their closest neighbor. So I'll zoom into this one. Once you have connected them, find the exact middle of that line and then add a perpendicular line to that. And then slowly start building them up. And remember to keep it light because a lot of these are gonna get cut off by each other. But that's the basic rule of Voronoi. So if I turn on my Voronoi again, see all these are in the same. They're following the same laws that made them. So even though when you see them without the math behind them, they seem a bit magical. It's actually quite easy once you really understand it. Even though this is all we need to know for my wheel, I wanted to finish off this Voronoi lesson by teaching you guys that this is just the 2D property of Voronoi. I'm using that to develop my pattern, and that calculation is fairly easy, but that doesn't mean that my wheel is a Voronoi structure. I'm just using the 2D structure of it. But if you want to see a 3D structure, it looks more like this. And as you can see, it's following the same properties that the 2D structure was following. There's a center point there and a center point there, and in the middle there's a plane. And once we eliminate this outer boundary, we can see the more dynamic center, and this really gives us a cool effect. Now, these are just random points, but when we organize the points, we start getting some really cool sculptures. And this spaceship I did was all math. I didn't model any of this. These are just curves and points and Voronoi. I have a tutorial on my site, and also I always use Voronis for movies and animations. It's a very beautiful thing, and I always tell people to really practice it because you can find some incredible stuff. All right, so this is the Voronoi Alpha 1 wheel system, and this is how it looks inside of Rhino. Before we actually get into the design of this and the workflow of this, I kind of wanted to go over a little bit on the grasshopper aspect of it. And if we look at my code, first you see that it's massive, and if I select all of them, you actually see all these hidden lines that are going through the whole algorithm. So there's a lot of stuff that even if you would sort of go and try to copy box by box, it wouldn't really matter because there's a lot of the important information is hidden, and not even on purpose, just to keep everything clean. And even I even have algorithms inside of my algorithm. So if I go here, I have even a little algorithm that I built too. So so this video is definitely not a step-by-step on how to write an algorithm to make the Voronoi wheel system. It's just to show you guys what this is. And yeah. So right now I'll go into, this is the surfacing mode, and down here you see I have these buttons, and actually if I press here and design, see now I get more of the curves. And if let me change the views. And this is the same thing we were doing with the other example that we made. See, we have the rotations, you know, the number of rows I want, middle spoke count. I get it. So the one I'll go sort of through the full range of them if I go max. That would take a very long time to calculate, but let's keep it a little more subtle. So I like that one. Then also down here I have that same graph mapper we used in the other example. So when another thing that is very valuable to this type of workflow is that if I go to the side view, see I have that profile here. So if I change the wheel size from let's say it's to 21, and then the tire width to like 285, and then the tire thickness to 35. These are all typical tire measurements. It will change all that, and all the numbers would correspond. Not only that, it's also in terms of the engineering criteria. Obviously, I know I am not an engineer, but I wanted to show how you know, if somebody was like, okay, let's get the center offset a little bit farther forward, or you know, 3 mils farther forward, or you know, that's very easily done. Or if maybe the width is too much, I could change it. And every little aspect you see is easily changeable. And one of the design aspects here is basically this is the accent curve, and I could change that in I could change how far out it goes and how exaggerated that design feature is. I like it very, very subtle. So once we actually figure out what we want with in terms of the wheel, excuse me. Now I'm gonna actually have my algorithm surface this wheel, and for this time I'm gonna leave it. I'm gonna record it so you guys can actually see the time it takes. So here I have my basically like cooker, and when I click here and I press surface. So right now what's going on is my algorithm is basically running through all the steps of CAD modeling right now, and it doesn't actually take that long. It only takes about 30-40 seconds. With something easy like this, it might be around 20 seconds. I don't know. But the point is that it's fairly easy to go from design to surface. And now see, now this is the finished result. And since everything is basically programmable, if I go here and I press this button, what just happened is we made our first wheel, and it sent that wheel to different places in my network where we'll use them later down the line. And that's basically how I do my wheels. So I'll show you a couple more and a couple of the other cool stuff we can do. Let's see. We could also have the attractor balance. If you see, I actually have this sort of basically a tractor that changes the scaling of my algorithm, and I could change the sizing of it too. I'm actually not a fan of this type of this exaggerated I think it happens a little too often, but I'll show you how it looks like. So now after this, I'm gonna surface it, but I won't make you guys wait. So here's a much more the attractors or the scaling of the middle holes and all that is very it's much more obvious. I don't like it, but you know, I wanted to show you guys what is possible. Another thing you should notice is that it has a sort of a fan angle, and in this one it's not really that noticeable. But if I and let's bake this out. So I go 2, and then I go like that. All right. So then I go back to my design mode. And actually, I want to show you guys. Those 3 numbers that you see aren't actually, they're not random numbers. The first number is the rotation. And the second number is the rows. And the third number is the spokes. So if we have something maybe like this, maybe okay. That's pretty cool. But I'm gonna eliminate, well, not eliminate, but I'm gonna make the scaling, and also the scaling, as you see it's right now in the middle. It's I could change it to wherever I want. So but I don't actually like I don't like that to be too exaggerated. I like it a little more subtle. Well, I feel like maybe that would look, and then we'll add a little more rotation. There you go. And then the angle is actually here in my wind spiral. So I'll add a little more. Okay, so now let's cook this. All right, so see, now you could actually well, I don't know if it's even easier to see it, but you can see how there's a bit of a spiral to my wheels. This one's crazy. And this is basically how I make all my wheels. And if you see here, these are all the numbers that we actually used for the rotation and the rows and the middle spoke count. And this actually helps a lot because a lot of times I'll be doing a bunch of these, and you know, I don't want to write them all down, so I decided to put them inside the actual design, and that way if I see an old rendering of mine, it's really easy for me to replicate it. But yeah, so this is basically the workflow of it. I'm gonna fast forward through the rest of these and just do a bunch, and then you can see how I'm doing them, and also I'll show you what happens afterwards because it's also really cool too. I wanted to talk a little bit about how I got here. When I started learning Grasshopper, I was already a senior level CAD modeler for the automotive industry, and I was already writing Python code for virtual reality experiences. So even though I already had a background in CAD and programming, this still took me about 3 years to learn. So this isn't something that's gonna happen overnight. And even to the people I mentor and teach, there's no shortcuts with Grasshopper. It's very technical, and it basically gives you the ability to build these tools. So even though there isn't a fillet tool or a freeform blend tool, you can easily build, not easily, but you can build them. And any tolerances or any degrees you need, it's definitely within reach. Saying that though, I still think that there's a lot of post processing with certain projects. So a lot of times it's not worth figuring out an algorithm to do it when I could just basically get like the hard edges, and then I take it to alias and add all my fillets and all that. Like a lot of times I let my algorithms take me 90% of the way there. But I do know that McNeil is investing a lot of money in this, and I am sure that every aspect will be made a lot easier and a lot more intuitive to use. So I think it's very much worth it to take the time and really learn how to use the software. Luckily now, there's more sources out there to help you learn. So I always recommend picking up Algorithm Aided Design by Arturo Tedeschi and going through every project in that book. I wish I would have picked up this book earlier because I think it would have saved me about a year of my time. Another one is ModeLab's Grasshopper Primer. It's a great source to sort of just gloss through. Another one is also my website. I always add tutorials, and on my YouTube, I'm gonna try to upload more videos that have to do with Grasshopper. And even in YouTube, if you Google Grasshopper, there's a bunch of videos out now that take you step by step. So it is a long journey, but I think it's worth it in the end because it really unlocks a lot of potential for these types of design workflows. Before we move on to the rendering aspect of this video, I wanted to show you real quick how easily I could 3D print these wheels. And with Grasshopper, the other bakes that you've been seeing were for my render engine. But now I want a different file type and structure for my 3D print. So I have a special bake for 3D printing, and when I click on it, it does everything I needed to do. And if I open up my 3D printing software and I open the file, see, here it is. It's already you don't really need to do anything. It's already closed. Since I already knew that I wanted to 3D print this wheel eventually, I set up my algorithm that way. So many of the actions were based off that principle. And let me rotate it. And then there. Now if I wanted to, this is obviously scaled down because I don't have a printer the size of a wheel. But if I wanted to print this, I could now. Let me show you the layers. Which really starts opening up a lot of potential for production because this model was developed immediately and then it was already set up for printing, so there wasn't anything to do. Theoretically, I could basically post up my algorithm and then people can be printing out their own wheels whenever they like. And a way to actually give people this control, there's actually companies like Shape Diver, that is actually working into putting parametric design into the web. So if you can imagine, obviously this is very simple right now still, but I could theoretically put on my website this wheel, and you could change whatever size you want. You can move around all the parameters, and then you'll get sent a finished off model. And then this way, it makes it possible for businesses to sort of give the design aspect to the consumer. So so it really starts opening up a lot of doors. Okay, so now that we're done with the modeling and designing aspect of it, I want to show you guys what I do when I want to render this. This is Modo, my favorite 3D modeling software, and first I need to do a couple things to get the data ready. So the first thing I need to do is convert this data into something that some down the line is better suited for rendering. And I also Python script. So here, this is just a Python I got off online called PyModo, and I need to convert the file from FBX to OBJ, and then I put where I placed those files. And so now what's happening is all my data conversion is happening automatically. I basically have figured out a way to automate almost every step of the process. So As you can see here in the top right, you can see that they're sort of like loading up and getting saved and loading up and getting saved. And that's basically all I have to do with all those different wheels that we just made. And right now I will show you the power of GPU rendering. So I'm sure it'll be pretty fun. Okay, so now that that is done, let me open up my whoops. Let me open up my file. And I guess we go to animate, right? And so here are actually all the files, all the wheels that we just made. And I've actually programmed it so that everything gets done automatically. and and basically that's sort of how I run my program. I do 10 wheels, and then and actually if I go into my render camera here, I actually don't even I don't even do my I don't like I let the computer do all the work, even the different views. So I just have to run this animation, and then I basically get everything done. And then also I don't use CPU rendering, I use GPU rendering, which is pretty crazy. Let me show you guys what that looks like. Right now it's getting loaded up into Octane. Octane is a GPU rendering. What you're about to see is actually 4 GPUs. I have 4 1080s, which I know sounds like a lot, but those 4 1080s cost less than one P6000. And it definitely costs less than a render farm. So let me show you guys how quick this this rendering goes. Actually, let me put this down here so I could control it. Ah, sorry. I'm gonna put this up here. There you go. So let me show you guys how quickly this thing goes. And so within about 40 seconds, like around less than a minute, I get the renderings that you've been seeing me post up. And this is also not even full scale. Actually, this is a 3K rendering. And so with GPU, I could actually start competing with people who have render farms, because they're so much quicker. Even though this has nothing to do with it, I'm actually gonna load up my other, actually the scene that you see in the background, just to show you guys. It's not exactly a perfect scene, but just to show you guys the power of a GPU rendering. All right, so this is Octane, and this is the actual Octane render, and this is Electra, one of a car I modeled to sort of help my business grow, and as you can see let me show you how quick this is. I'm just right now browsing around, and the second I let it go, it starts to really look almost perfect. I do understand that this scene isn't perfect. I don't think it's perfect at all. It's just to showcase the power of GPU rendering. My workstation, well, honestly, it's more of a high-end gaming station. I use I think I have 4 cores, 4 gigahertz i7, I think, and my GPUs are regular gaming GPUs, so they're really not that expensive when it comes to other solutions. So let me change around the colors and stuff. And this scene, what you're seeing, those trees aren't like images, aren't they're real trees. And if let me get closer, you see all this, all you're seeing. Ah, sorry. There you go. That's all real geometry. So every leaf is real geometry. Every tree is real geometry. And let me get back so you guys can see a tree. Oh, there it is. So this is the power of GPU rendering. To me, it's incredible. I don't understand why people spend so much money in other solutions. Octane is I have a standalone license of Octane. I think it was $600, and that's it. There's no monthly payment. There's nothing. My hardware is probably less than 6,000. And now I could do things that before it would be impossible unless I had a render farm and I was paying $1,000 a month for some software. But now with this new technology, it's very easy to compete and not have to worry about these types of costs. Let me go black. Black is pretty cool. And this is an old file. I'm actually going to release an updated version of Electra with some parametric design and my wheels in there. But I've been a bit busy with client work and with the Voronoi Wheel system. But see, I kind of just want to quickly show you guys the power of GPU rendering. All right, so we are almost done, I swear. I'm sorry for taking too much time, but I always got a lot of stuff to say. That's just how it goes. I actually wanted to show you guys my tread, and my tread I actually is also parametric. And let me show you some cool little tricks, and I'll show you exactly how it happens. Once I press refresh, there you go. I added sand, and very exaggerated sand. But I want to show you guys what I'm actually using. I'm using a Substance Designer, and and the reason why I started learning, I just started learning Substance Designer. It was my goal for this year, and if you see here, it has a very similar workflow as Grasshopper. I actually met these guys I think 2 years ago, and the second I saw their workflow, I knew that I needed to learn Substance Designer because it gives me. I saw that it gives me the same power that Grasshopper gives me, but for texturing. So it's very much a very similar workflow in terms of this node-based information going through these boxes and coming out, except it's texture-based. And then this gives me, so once I hit this, I could go here and I press re-export, and then that's it. All I have to do is refresh my render engine, and then you'll see how this changes. And this is really an incredibly powerful workflow, and I plan to become very good at it. But I just started, so don't judge me. And but even then, I've been really getting into it maybe this past month, and I already developed this nice little tread, and it wasn't really. Oh, whoops! I forgot to export it. Give me 1 second. And it was actually wasn't that difficult. And I want to show you guys some of the stuff that of why it would be so convenient to use this workflow. Let's say for example this little one right here. I don't like how short it is. I kind of want to get it back to the middle. I could go back into. Let me find. Excuse me. I should have practiced this before I started recording. Uh, I know what to do. It's right here. And then I gotta go here and go here. So and actually here inside of Substance Designer, you see a little preview of what's going on. So if I move this way, did I go the right way? Yeah, I went the right way. Oop. There you go. If you can see, this is going farther in, and then all I gotta do is re-export. And then once I hit refresh, if you focus on this little, I guess would be like tread pattern, I guess. And as soon as the file, the render engine reloads, see, there you go. So now I could have I could use this to have the same approach that I do with modeling, but with texturing. And to me, that's also extremely powerful. Obviously, this is the beginning of my journey into a substance designer, but I'm sure I'll eventually master it too. I don't know if it'll take me a year. I hope not. If you actually want to learn a substance designer, first off, it's extremely I don't want to say cheap because it's a really great program, but it doesn't cost that much money. The I think it's I pay $20 a month, and it gives me access to Substance Designer and also Substance Source. And there I actually that's why I got let me load it up. All right, so this is Substance Source, and as you can see here, I have 177 downloads left. I've been using Substance for a while now, so every month I think they give you a certain amount. And actually, before I started texturing, I would actually only use it as basically a texture library because either I could go online and search for any concrete that I want or a tree or whatever pattern, but it was taking me way too long to find all the data that is needed. And with Substance, it actually gives you everything, and it's parametric. So that means that it was really valuable to me when I was doing VR, because for my high end rendering, I could put the resolution to something up to 16K if I wanted to, and then for my more OpenGL files that don't want those big textures, I could lower it to whatever I want. It's the same mentality as with the Grasshopper. You could change all the parameters, even though these look like pictures. A lot of them are, some are, but a lot of them are actually completely parametric. And and if you take this, especially with the fabrics, it really gives you a lot more options. And I'm very excited to really dig deep into this. And actually, they invited me to speak in their event, Substance Days, which is coming up I think in 2 months. So it will be live broadcasted, and you could see me make a fool of myself probably. But yeah, I always recommend it. This is awesome. Only $20 a month. So this does conclude our the end of my process. I'll just start loading up all the renderings we did of all the different wheels that you saw me develop. Yeah, so just some, I guess, final words. Thanks for watching. I don't think that my process is the most best correct process or whatever. I do believe that I'm just showcasing how I like to approach design, modeling, and rendering. But before that, I've been 3D modeling since I was 11. So sometimes I love polygon modeling. I love NURB modeling. To me, parametric modeling was just another extension of that, and it does take a very long time to learn. But I think if you try to keep everything in this workflow, it ends up it becomes so valuable, and it's really actually helping me compete with businesses that have a much higher budget and much better equipment. But honestly, I don't need any of those things to really to do what I need to do for my clients. And yeah, so my name is Raimundo Burgueño. My company is Handlebar 3D. If you're looking for some sort of work that you saw here, let me know. Send me an email. Um, I always, like I said before, I always reserve time in my month to do these videos and show and make some articles. So remember to follow me in whatever social media you'd like, or just check back on my website. I hope you guys have a great week, and I hope I didn't bore you too much. I'm sure you guys are over listening to me speak. So thanks for watching, and I hope you guys have a nice day. Bye bye.